So this is another look at the pulley here. It's a pretty simple deal. I've got some 2-inch aluminum that we're going to be using to make this. So we'll chuck it in the lathe, pretty simple operation. Do a drilled hole, bore it to size, turn the OD to size. We'll do an undercut here for the pulley and then part it off, and we'll probably chuck it back up and face it, clean that other side off where we part it. There's a couple of set screws we'll have to drill and tap. And I did look through all of my broach tooling. I found a 20mm broach plug and a 6mm Dumont broach there. The only thing that I do not have here in this shop to be able to complete this is a press. So once we get this done, we'll be moving up to the home shop so that we can broach our keyways in there, and then that'll finish that up. So this piece of stock already had a pilot hole and well, there's a 3/4 hole there for the last part that I made. So that's a good size hole for us to start with to bore it out 20mm. So we're just gonna go ahead and open up that center bore. Go back in there with a 1/2-inch drill to pilot it, and then we'll follow it up with that 3/4. 3 inches deep, by the way. Get a little bit of cutting oil in there so the chips will stop sticking. All right, there we go. We got to watch those brand new drills. Things are razor sharp. Sliced my finger right there cleaning that 1/2-inch drill off, but I think we'll manage. Go in there with our 3/4 to finish this out. I've got the boring bar set up to get in there and finish out our 20mm bore. So I'm using my Micro 100 Micro Quick boring bar. This is the 3-inch length right here, which is working out perfect because that's the exact length I wanted to bore it to make both of the parts. This is what the Micro Quick bars look like right there. The way that they designed these is that they have that angle on the back, and on the holder there's a pin in there. So when you slide this in, it squares up the tool so that the point of it is on the center there. And then the set screw on the back side goes down into that ground area to lock it in place. So these I really, really like these boring bars, and I've got a few different sizes of these, and also some grooving and threading tools there as well. But just want to point that out because these are just one of my favorite carbide bar setups to use here for small bars like that. I'm also continuing to get used to the digital readout here on the Precision Matthews. It's such a nice feature to have. All the years that I've gone without having DROs on my other lathes, this is really, really nice. So, you know, I've got a Z0 there to go to, and I've actually got the X set on the diameter there. And of course, we'll use our mic to make sure that we get it there to pinpoint it on size. Should be around 0.787, I believe. But I just made a 5,000 skim cut in the bore there, mic'd it with my telescope gauge and micrometer, and set it to what I mic'd it at. So we should be able to, you know, use that to kind of get us very close to our finished bore size. So we won't need to take but just a couple passes through there to get this finished up on the bore anyway. We'll go ahead and finish up that skin pass through here, total of 10 thousandths. The chip breaking is one thing that you got to kind of deal with using these solid bars. It's not really a chip breaker molded into that or ground into that. I'm going to stop at a 1/2 inch. I want to make sure that, yeah, I see the chips. I want to make sure that bar doesn't bind up and snap off on me. I doubt that it will with this aluminum, but these chips can play havoc on that. So that was, I was at a 1/2 inch on my Z. Bring it right back into 0.5 and just keep it going. It's going to go right up to the face of that bar holder, and that's it. Pretty slick. So just going to keep working this to bring it out to our 20 mil size. This is going to be our final pass, put us on 0.787. Okay, we're going to turn the OD. This is going to finish out at 41 millimeters on the OD there. So I've done the same thing. We've skint the OD very lightly, and I've got the DRO set to this exact diameter, so we'll be using that to kind of sneak up on our size. These outside diameters aren't going to be super critical, but we'll hit them on their nominal size anyway. It looks like there's some kind of flat belt that possibly runs on this right here. So that tool, by the way, that's a CNGP 430 insert. Works really good on aluminum. Five thousandths to go. Looking for 614 or 41 millimeter. I think that's going to be close enough right there. 614. All right, so now we just need to go in there. We got to do our little undercuts to match this right in there, that diameter. All right, we're going to machine that undercut. I'm going to go ahead and use this parting tool for both plunging and side to side. I know it's not, this particular one is not designed for side turning, but you can use it if you're just not taking a very heavy cut. If we're just cleaning it up, it'll work out pretty good. And what I'm using the DRO, so we are going to be using our metric. So we're on a 41 millimeter diameter right there, and I've got it touched off, and we're going to be taking it down to 37 millimeters. So I should be able to just watch our X movement, bring it down to 37, leave a little bit to clean it up. Our Z, I've got it calculated at 18.82 millimeters because of the width that we want. I believe it was 22 millimeters is our width there. That parting tool is exactly 1/8 of an inch wide, 0.12 inches. So I just did our calculation, converted it to metric. So that should be our total Z offset, including the width of the tool there, which will bring us at our 22 millimeter wide on our groove. Let's give this a go, shall we? I'll bring this down just below, or just above, I'm sorry, to 37. Let's just try 0.5, that's 37.5. So now we can just continue to move this over and just eyeball the width. Plunge it in at 37.5 on the DRO. We're just going to keep moving this tool over until we get our 18.82 on our Z. It's funny because when you're doing this stuff, you're not even really watching the cut. You're looking up here at the digital readout. Just looking at those numbers come into what you want. All right, one more wide cut and then we should be at our finish. 16.7, so what we want is 18. I'm gonna leave a little bit. I'm gonna go to 18.5 right there. That'll give me a little bit to clean up. So, all right, so what we'll do, let me see which way I'm feeding here. I'll just keep it going to a negative position. Let's come in here to our, let's see how this does. I'm only taking about 1/10 of a millimeter there, or 0.1. See, that's doing pretty good. That's even leaving a nice finish on there too. Let's come in here and try that again. 0. This is at 37.3 millimeters, so we have 0.3 to bring it down the size. We'll mic it before we finish that last pass and just confirm where we're at. 18.8, oh sorry, 18.5. All right, I'm at 37.2. What I want to do, I'm going to go ahead and get that shoulder cleaned up closer to our size. Bring this down to 37.2. Right there. $37.1. That should leave us with one more cut there to clean that up. I'm just going to stop the machine and I'm going to do some measuring there to verify our diameter and our width. Let's just go ahead and mic this guy and see about where we're at. I'll go over there and convert this to see where we are. So we're actually really close. We have 0.05 millimeters to bring that to our diameter, so not much at all. We'll make one more little cut on that, and because the camera mount's in the way, but look at that, we're on 22 right there on our width, so we're perfect. All right, let me go ahead and we'll kick this on and finish this last pass. Bring it back to our 0. I'm gonna go down to 37.05. Right there, that should be it. 37.05 on the DRO. $18.8. That should be it right there. All right. All right, we're gonna go ahead and part this guy off. I'm just leaving myself, I don't know, about 25, 30 thousandths to face off the back side to clean it up and chamfer it. Stick this is just a little soft rod that we're gonna stick in there to catch it. And we should be ready to go. Using a high-speed parting blade for this, by the way. Keep a little oil on it. There we go. Okay, so we're just going to duplicate this one more time on this second piece there so that we can get to our last facing op. But that worked out pretty good there. All right, we got both our pulleys parted off, so all we got left to do is just face this back side and do our chamfers. So let's just do a measurement there, see about where we're at. So it looks like 31.08. We want to finish it out at 30 millimeters, so we'll continue to use our digital readout to our advantage. We'll touch the tool off and then set the Z at 31.08 and just bring it into 30 millimeter to clean it up to size. Get my feed set here. Let's come in here and just barely touch this. We'll try that right there. I kind of split the difference. I'm going to go ahead and reach up here. Our Z 31.07. I don't know if you guys can see the DRO Z. We've got it set at 31.07. Let's just go ahead and move it in a little bit, about 30.5, and we'll base that off. I'm going to leave a little bit there to clean up on the face. Just make like a nice clean up cut, I mean. It's doing pretty good. I'm going to use a little drop of oil. And what I'm going to do is just take it to 30.1. Right about there. And I'll measure it, make sure we're not overshooting it. .1, so we're matched up. Our width is matched up to our DRO there, so we'll just go ahead and take that last 1/10 off of there, and it'll bring it right there to size. I'll verify it, but that should be it there. I think we're there. All right, I finished up the facing and the chamfering on both of these little pulleys right here. We'll go ahead and give them a little width check on dimension. Looks like that one finished out 30.02. .01 on our 30 mil width right there. All right, and then like I said, I went ahead and chamfered them too, so got that done. Next thing, we've got a couple of small set screws. It looks like there's 2 of them that's drill and tap like 90 degrees apart. I'm probably just gonna do that off camera. You know, you guys see me drill and tap plenty of times. Clamp it in the vise, drill it, tap it, and it's done. I'm going to be going with some standard set screws though, because I don't have any metric set screws here on site, but I have a little case of standard size there at the home shop. So I'll probably drill and tap it for like, I don't know, 1032 or something like that. And then we'll ride up there to the home shop. We've got this is our 20 millimeter broach plug. And let me see, hopefully it'll fit in there. Look at that, perfect fit. There we go. So we'll broach out our 6 millimeter key, And then once we do that, this job will be done. So I'm gonna get the drilling and tapping, just an easy little thing, and then I'll bring you guys back when we're ready to broach our 2 internal keyways. As usual, I lied to you, so I'm gonna go ahead and get you a couple shots of this drilling and tapping. It'll be pretty simple. Usually on little parts like this, it's not super critical unless it calls out to be on exactly 90 degrees or whatever angle. So I usually just put the drill in there like that, and I stand down here and look straight in on it. And when that thing looks straight and looks square, it's where it needs to be. So that is just about dead nuts on 90 degrees right there. Okay, so we've got the drilling and tapping finished up on both of our pulleys there. I did mine at 90 degrees apart. It worked out good. So I ended up using a 1032 set screw because I've got those, and it's the same size as actually what was in this one right here as well. So that worked out pretty good. Now you might notice that whoever made this, they did not put a set screw over the key. I'm gonna opt to put the, I'm gonna have a set screw over where we broach one of the keys. That's kind of industry standard practices there, and it's not going to hurt a job in one way or the other for it to not be for it to be over the key, I mean. So I think it works better when you do that, so that your set screw is applying pressure downwards against the key that's in the shaft, and will keep that key from trying to rock at all back and forth during use. So that's the way we're going to do ours. They didn't have any kind of, there's nothing symmetrical about how they did their set screws and their key on this guy right there. So I don't know what they were thinking or why they did it the way they did, but this is just how this one looks. So one more op left, go broach our 6mm key. We're gonna run up to the home shop to do that, to get this finished out, and then that will complete this, this job, including the 2 shafts that it goes to. We're set up on the Kent Moore press, and we are ready to go. I'm using anchor loop for our coating fluid there. All right, that went pretty good. So we'll have to put the shim in there and cut it one more time. Knocking the chips out of there, and then we'll add a little bit more lubricant. Yeah, I need to get it out here so I can tap on it. That's just to get it started. what I like to do is to bump it in there and then back off just to make sure that we're pressing nice and straight whenever as we go in there further with our broach. Do like that, straighten itself up. Just checking it, make sure it's not pulling away from the bottom there, because a lot of times these broaches want to pull in as it goes down there deeper to it. So I'm just trying to make sure that we do not do that. I think our broaching turned out nice. We're going to go ahead. It should be only one shim is what we're going to need. Anyway, there it is. We'll just have to do a little internal deburring, get that burr off the inside corner there. That should be good to go. And we got one more to do.